Hello children, this is another good example from our syllabus, appeared previously also in the board examination. The question is, a circle is given to you, line L is a tangent to the circle at point T, segment AP is perpendicular to line PQ, segment BQ is also perpendicular to line PQ. Segment AB is the diameter of a circle. We have to prove that segment CP is congruent to segment CQ. Proof is very simple. Line PQ is a tangent to the circle at point T. Therefore, segment CT will be perpendicular to this line. In other words, angle CTQ, this angle will be a right angle. We have written by tangent theorem. Angle APT, angle BQR, they are right angles, they are already given. Perpendicular means by definition they are forming a right angle. So, this angle is a right angle, this angle is a right angle, this is also a right angle. All the three angles are 90-degree angles, and therefore they are congruent to each other. If this angle is congruent to this angle is congruent to this angle, that means all three corresponding angles are congruent, and therefore these three lines will be parallel to each other by corresponding angles test. Because corresponding angles are congruent, this angle, this angle, this angle, these are corresponding angles and they are congruent. Therefore, these three lines are parallel to each other by corresponding angles test. When we say that these three lines are parallel, we have the property of intercepts by three parallel lines. And the property says the ratio of intercepts on one transversal, that is PT upon TQ, this ratio will be equal to AC upon CB. Okay? The property of intercepts by three parallel lines says that the ratio of intercepts on one transversal is also equal to the ratio of intercepts on the other transversal. So PT upon TQ is equal to AC upon CB. But AC upon CB will be equal to 1 because AC and CB are both equal, radii of the same circle, and therefore the ratio will be 1. Okay, so if you cross multiply, you get PT is equal to TQ. So you have reached to the conclusion that PT and QT are congruent segments. Now we shift into triangles, triangle CTP and triangle CTQ. Segment CT is congruent to itself, self-congruent segment. These two angles are congruent using 1. Okay, both are 90-degree angles. Reason is correct. Then segment PT is congruent to segment QT from 3. So this is a self-congruent segment. These two angles are congruent to each other, being 90-degree angles. Segment PT is congruent to segment QT. We have already proven in equation number 3. Therefore, these two triangles, triangle CTP is congruent to triangle CTQ. CTP is congruent to triangle CTQ by SAS test. And therefore, segment CP will be congruent to segment CQ. Segment CP will be congruent to segment CQ. And this is what we had to prove. Segment CP is congruent to segment CQ. A good example. We need practice to write the example.